Alright, so today we're going to talk a little bit about these LiPo batteries here, and the only reason I want to talk about this is because some of these batteries can actually get a little bit inflated if handled improperly, and since it's a lithium polymer battery, these things can rupture and interact with the atmosphere and explode, ignite on fire, and all bad things. The other thing that's really just economics, this is a $45 battery, so if you destroy this, I mean, that's quite expensive. These are no big deal, these are only like $10, but these bigger batteries are really expensive, so we definitely want to make sure we take care of them. So you look at all these batteries, they're all LiPo batteries, but they're all different sizes, and so the difference between them is that is the cell of the battery and the milliamp hours. So all of these batteries here are 3-cell batteries. You can see there's a 3-cell here. And so each cell is 3.7 volts, and so if you do 3 times 3.7, you get 11.1. And then these guys are 2-cell batteries, so if you do 2 times 3.7, you get 7.4. And so that cell rating is the nominal voltage. So although these guys are 3 cells and they're all nominal 11.1 volts, this guy is actually 5,400 milliamp hours, and versus these guys are 3,200 milliamp hours. So these two will actually last longer, run out of juice faster than this guy, and then obviously it's a little bit heavier. So once you look at that, then you start talking about charging the batteries. But before we get to that, let's just talk about the voltage here. So this guy, if I actually plug this in, there's a difference between the nominal voltage of 11.1 and then how much voltage is actually in the battery. So this is a fully charged 3-cell battery. So if I plug this in and I look at the voltmeter, it actually says 12.6 on there. And so the peak voltage of one cell is actually 4.2. So if you do 3 times 4.2, you get 12.6. And so that's how you know that this is a fully charged battery. If you look at this guy, though, I actually just bought this guy. It's an 11.1 volt battery, so again, fully charged would be 12.6. But since I just pulled it out of the box, straight from the packaging, this guy is only at, 11.4. So it's just a little bit over the nominal voltage, okay? And so if I plug this into the charger here, it'll actually charge up to 12.6. And if I plug this into the airplane, it'll actually discharge down to its minimum voltage. So when you plug a LiPo battery in, most flight controllers on aircraft will have an auto shut-off feature. So once it hits a minimum voltage, it will turn off. Now, if you accidentally leave the battery in, even with the switch turned off, and you just have the battery in, this battery is actually still discharging. And so if I actually plug this guy into the voltmeter here, the nominal voltage is 11.1, but this guy is actually only at 5.4 volts. When the battery gets below 3 volts per cell, so that's 9 volts for this guy, you're going to run into a lot of trouble. And you can see here, that's why this guy's puffed up. So this guy is more, too far gone at that point, in my opinion. So if we look at this battery, this one's also fully charged. It's a 2-cell battery, so 4.2 times 2 is 8.4. So if I plug this guy into here, and this is really bad practice to plug this in without having these two leads plugged in, because if you have them touch, you'll get a lot of sparks, which the guy filming, he knows that really well. So I'm going to plug this in just so it's easier for me to check the voltage on this guy. So if I touch this guy and touch this guy here, that guy is, if you want to zoom in on that, we got, about 8.35. So that one's fully charged. That's a 2-cell battery there. Now, this guy was actually plugged into an Arduino, and an Arduino runs on 5 volts. So this battery will power the Arduino until the battery hits less than 5 volts. The problem is that since this is a 2-cell battery, the minimum voltage for this thing to operate safely is 6 volts. So it actually means it'll still power the Arduino even when you've gone below the minimum voltage. And so if I plug this battery in to these connection leads, and luckily you can't plug this in backwards. Let's see here. We have like 4.95 exactly. So basically it ran all the way to 5 volts, the Arduino shut off, and then this thing stopped discharging. But now the voltage is so low that if I plug this into the charger, and so what you want to do when you're charging is every single one of these batteries, if you look, they all have discharge leads and they all have charge leads on every single one of them. And so you want to have the discharge lead plugged in, but you also need the charge lead plugged in. And there's like a million of these here, but it's pretty hard to plug it into the wrong one. And so I usually have the battery plugged in like that, and then I'll go ahead and plug this into the wall. And so the whole thing will do its little power up sequence. And so right now, because I charge this battery all the time, it's already set at 0.4 amps. and then 7.4 volts, which is 2 cells. Now, what I usually do for rule of thumb is that if you look at the milliamp hours, 430, and if you divide by 100, you'd get well, actually, I guess 1,000, not 100. If you divide by 1,000, you get 0.4. And so this guy, you can actually charge this guy at 3 amps if you wanted to. And this guy, you could even charge at 5 amps. Now, this battery with this connector here only charges with this charger. So this is the quadcopter battery, so if you're not doing any research with the quadcopter, you should not be using this charger at all. So don't try and take this battery with this connector and try and jam it into a different connector. You want to make sure that you go grab the correct connector for this guy and then plug it into the correct charger. So again, I'll just repeat that, don't use this charger unless you're actually using these batteries here. This guy is fairly straightforward. You just have LiPo and then 3 amps. You plug in the discharge lead, the charge lead, plug it into the wall, and it has everything is automatic.
Actually, if you try to, I was reading the manual, if you try to plug one of these smaller batteries into it and charge it, it won't allow you to.
Oh, really? Okay, so then there's a safety feature built into that one. The safety features built into this one are also quite nice as well. So this one's already set at 0.4 amps and 7.4 volts. So if I hold the start button to try and charge it, it's going to do a battery check, and then it's going to freak out on me and say that the cell is low voltage. And remember, this is the bad battery, so this one won't charge. So if I unplug this then, and I try and plug in the good battery, and then plug this guy in, and then hold this down, it's going to do a check. Battery's good. It says that it's reading 2 volts from the battery, and it's about to send 2 volts, or sorry, 2 cells, I'm sorry. So then you just hit confirm to start, and then it'll start up. This thing will beep at you and auto shut off once it's done. If you are freaking out, if the battery gets hot, or you need to leave for the day, just go ahead and unplug it from the wall, and never leave the battery unattended, obviously. Honestly, they recommend that you actually put the battery inside the LiPo stack, but as long as you're here and in the room and you're present and you're monitoring it, you should be okay. So let's say we wanted to charge this bigger battery here, which I actually need to for a flight test later this week. I can go ahead and plug this guy in here, and then plug these leads over here, and then take the charge lead. And again, this one's a little bit bigger, but you just find the right port that it plugs into. We can plug this in, and so now we have to change the settings, and so we can move through this. And so this is a 3200 milliamp hour battery, so I can jack that up to 3 amps. I get a little afraid, so I'm just going to do 2.5, and then I'm going to increase that to 3 cells, 11.1 volts. So hold it down, battery check, everything looks good, and then so it's going to go ahead and charge, and then that's it, and then it'll beep at me when it's done. This guy, like I said, so these 2 bad batteries are far gone. I'm going to try and see if I can charge them at the nickel metal hydride setting to override the battery check on the charger, but that's not recommended at all, and I'm going to do this off camera because if these batteries do get hot, I'm going to have to do that, and hopefully they won't rupture or explode, so we'll see. Rockwell, do you think I missed anything?
No, I do not.
Alright, cool. Well, at this point, you've watched the video, so
If you have any questions,
you can go ahead and say that you have watched the safety video, and then you can operate all this machinery. Again, if you do have questions, ask me or anyone in the lab. Most of the grad students know everything that's going on. And then you can always call Hobbytown too. If you just, Google Hobbytown, it should be good to go. Cool.
Alright, later.
Fade to black?
Yeah.
Alright. Okay, you want to try and bump this guy up?
I hope that means it's saved.